Good morning to one and all. Today we are going to discuss about water softening methods. Before discussing this topic, let us discuss what is the current relevance of this topic. The war of the 21st century will be fought over water. 70% of Earth's surface is covered with water. Still, more than half of the world's population do not have access to pure drinking water. When the scientists all over the world looked into this issue, it was understood that a major share of water available to us is contaminated. In most places, the water available cannot be used for household activities such as washing, bathing, etc. because the contaminants present in it make it hard water, which makes soap insoluble. So today we are discussing about how can you overcome this issue. Hard water means the water that contain salts of calcium, magnesium and heavy metals, principally which is linked with bicarbonate, chlorates and sulfates ions. Calcium and magnesium ions in hard water react with higher fatty acids of soap to form an insoluble gelatinous curdy precipitate. They cause the insolubility of the soap, or which cause the wastaging of soap. So we have to remove that contaminants from water. That is actually known as softening of hard water. A lot of methods are existing to overcome or to remove this hardness causing substance. Some of them are ion exchange process, reverse osmosis, distillation, lime soda process using zeolites, etc. The main topic is ion exchange process. Let us discuss the principle. Ion exchange is a reversible chemical reaction where an ion form solution is exchanged for a similarly charged ion attached to an immobile solid particles. These solid ions exchange particles are either naturally occurring inorganic zeolites or synthetically produced organic resins. On the basis of existence, these ion exchanges are classified into two. They are natural ion exchanges and synthetic ion exchanges. Natural ion exchanges are the ion exchange resins which are exist in this world. Synthetic are the substances such as zeolites which are human made. Let us discuss the process or how this ion exchange process happen. Mainly, it is a polymer that acts as the medium of ion exchange. It is in form of small microbuds, usually white or yellowish in color. You can see. The buds are typically insoluble, cross-linked, high molecular weight organic polymer having a porous structure with exchangeable ions. These resins are mainly classified into two. They are cationic exchanges and anionic exchanges. This classification is given on the basis of functional group which is present in it. Cations exchanges are the exchange resins which remove the hardness causing cations from water. At the same time, they provide or they give the cations which do not cause hardness. It is of mainly two types. Maybe it is of strongly acidic in nature. In strongly acidic resins, which consisting of functional group derivatives such as SO3, sulfonic groups, etc. Or it may be weakly acidic in nature, in which the functional groups such as carboxylic acid, COOH, may be present. When we pass this hard water through these resins, the active species is H plus ions. These H plus ions will be given into water, and the hardness causing cations such as calcium, magnesium, and heavy metals is taken up by the resins. So that cations may be removed. But we know that not only these cations is responsible for hardness, even though it is the anions is also responsible for that. So we have to remove this anions also. On the basis of the nature of exchanges, we can divide these anion exchanges into two. Similarly, in the classification of cation exchanges, they may be strongly basic in nature or weakly basic in nature. Strongly basic anionic exchanges consisting of strongly basic functional groups such as quaternary ammonium compounds such as RNOH, etc. If it is weakly and basic in nature, which may be the derivatives of primary or secondary amines. You can see there is one example for that. Then let us discuss the procedure. First of all, we have to take this raw water, and first of all, we have to give that, or we have to put that water into cationic exchanges column. Let us discuss that. In this water consisting of calcium sulfate, calcium is a cation which is responsible for hardness, and sulfate is an anion which is responsible for water, and we are passing this water through a bed of cationic exchange, and which is filled in a cationic exchanged column. During this water is passed through that, the cations such as calcium will be taken up by the cationic exchanges, and these cationic resins give that give H plus ions or the hardness, the ions which do not cause hardness into water. So they take up calcium ions and they provide H plus ions. So after some time, or by passing this water through this cation exchanged column, most of the cations which is responsible for hardness will be taken up by this cation exchange resins. But the problem is not so removed. We have to remove the anions also. So what we have to do? We have to take that water from the cation exchanged column to anionic exchanged column to remove the hardness causing anions. So earlier I said that this water consisting of calcium sulfate, which in cationic exchange column the calcium is removed. Then we have to remove these anions such as sulfate and chlorides. When we pass this anion exchange, or the anions through anionic exchange column, the anions which is responsible hardness will be taken by these anionic exchanges. At the same time, they produce or they give OH minus ions which do not cause hardness. From the outlet or the water which is obtained from this will be does not contain any hardness causing, and the water obtained is demineralized. Then you can see there is some dilute NaCl and a dilute NaOH. Let us think that if a polymer molecule consisting of 1000 molecules, By passing water through that after some time all the H plus ions or the active species get donated to water, and at the same time that polymer will be absorbed by these calcium ions. So after some time this polymer will incapable to remove the hardness causing cations. So what we have to do, we have to use this 3R principle. We have to reduce, reuse and recycle. Here for recycling, for the regeneration process, we have to add dilute HCl. This dilute HCl, again, if you pass dilute HCl through that, what will happen that these H plus ions will be taken by these resins and the calcium ions will be descended. Similarly, these anions, when we pass NaOH, that anions which cause hardness will be removed and OH minus will be removed. So these are the process which is discussed. That's about today's topic. Let us thank you.